Okay. So recall. Okay, you recall in the last class, you have learned how to get the Laplace transform done through the definition. Okay, meaning that you have to do the integration. Then you will get this Laplace transform formula. And today we will look at how to use this table to get the Laplace transform done. We look at this example. Okay, let's say we want to Laplace transform ET. Okay, Laplace transform ET. So we will use this formula. Okay, this formula. So ET, that means A is 1. Okay, A is 1. So you just substitute A by 1 here. So the answer would be 1 over S minus 1. Okay, this is the formula. You just compare the given question to the formula, identify the value of A. Okay, A is 1. So just substitute 1 here. So this is the solution. Okay, when we Laplace ET, we get this. Okay, very simple. And this T, when your function is T, so this is T to the power of 1. Okay, so we will choose this as the formula. Okay, from the list, first of all, you have to look at your FT. It belongs to which category? Okay, so T, that means you have to choose this. Okay, so we will use this formula. Okay, we use this formula. Then when your N is 1, okay, identify N is 1 because this is T to the power of 1. N is 1, so you have 1 factorial over S 1 plus 1, which is S squared here. Okay, S squared. 1 factorial is 1. You can use your calculator to get the value of the factorial. Factorial means when you have 3 factorial, it is 3 times 2 times 1. When you have 4 factorial means 4 times 3 times 2 times 1. Okay, you can get from your calculator. Okay, the third one, when your function is sine 2t, okay, sine 2t. So you will find, okay, from the list of formula, sine 2t, you have to use this formula. Okay, this formula, okay, this is the one. So you identify the value of A. Okay, so sine 2t, this means your A is 2. When A is 2, you substitute the 2 here. So you have 2 over S squared plus 4. This is the answer. Okay, this is the basic, okay, the most basic one. Okay, now we try this exercise. Okay, we try this exercise. Okay, FT is 1. Question A, FT is 1. A, FT is 1, meaning that we are doing the Laplace transform for 1. Okay, we're trying to get the table of the slide. Okay, so Laplace one, find from the table. Laplace one is 1/s. Okay, 1/s. Okay, this is the most simplest one. Okay, for b, b is e negative 2t. Okay, e negative 2t. The 1/s, a is negative 2. Okay, a is negative 2. So s minus negative 2. You get a plus 2. Okay, identify the value of a. Okay, next one is t squared. Okay, t squared. So n is 2. Okay, n is 2. So we have 2 factorial s 2 plus 1, 3. Okay, 2 factorial is 2. Okay, for question D, cost. We know that for cost, we have to choose the cost AT. But the formula given is only for AT, A times T. But here you have 2T minus 5. So before we apply the formula, we have to simplify. We have to expand using the identity of the triple function. Okay, cost. This is cost 2T minus 2 pi. Cos A minus B. Cos A minus B is cos A, cos B plus sin A, sin B. Okay, identity will be given in the final exam. Okay. So you just need to know how to use the identity. Okay, what is cos 2 pi? Cos 2 pi is 1. Sin 2 pi 0. So meaning that this is equals to cos 2t. Okay, cos 2t. Then I continue here. Okay, cos 2t. So A is 2. A is 2. We use the cos 80, yeah? 1 cos 80. So when A is 2, you have s over s squared plus 4. S over s squared plus 4. Okay, look at the formula from the table. We have a sign 5t. Okay, hypersign 5t is a over s squared minus a squared. Okay, so for this Laplace transform, make sure your 5 looks like 5, s looks like s. Okay, do not confuse yourself and me. Okay, because student they did have this kind of mistake. 2s, 2s, then lastly 25. Or 25, 25, lastly 2s. So s and 5 must be significant difference enough. Okay, different enough for you to recognize and also for me to recognize. Okay, so next one. Look at the first property of the Laplace transform. Okay. Okay, this is the first property of Laplace transform. Okay, what you have learned today will be covered under midterm. Okay. So when you have alpha and beta are constants, okay, when alpha, beta are constants, and this is linear combination of two functions. So when we want to do the Laplace transform, we can separate this into two, okay, because we have different functions, ft. And when you have a constant, you can factorize the constant. Okay, factorize the constant, and we just Laplace transform the function in t. Okay, for example, this one, 3e negative 6t, and then minus blah, blah, blah. Okay, we can break this into three parts. Okay, three parts. This one, 1, 2, 3. And we just factorize the constant. Okay, -2, and then +4. Okay, we just Laplace transform the exponential cos 3t and t cube functions. Okay, and this one we have already know how to get the answer for this one, and this one. Then finally simplify. Okay. Now let's try this. Try some exercise. Okay, we just Laplace transform the t. Okay, Laplace t squared plus 2 Laplace cos 5t minus Laplace sin 3t. Be this. Seven times or your attendance. Attendance. Okay, t squared, n is 2. 2 factorial over s cubed. Cos 5t s over s squared plus 25. Sin 3t is 3 over s squared plus 9. So just simplify this as negative 6 over s cubed plus 2s over s squared plus 25 minus 3 over s squared plus 9. Okay. B, your ft, you are given ft, okay? So your fs will be, okay, you can start to Laplace. After Laplace, we get F in S. Okay, after Laplace, okay, we write this formula. I have a cos to t. I have a cos to t. A is 2. S over S squared minus 4. I have a sine. A is sub 3. A is sub 3. S squared minus 3. Sub 3 squared is 3. Okay, to simplify, 4x S squared minus 4, 3 sub 3, S squared minus 3. Okay, e negative 2t, EAT, where a is negative 2. Okay, a is negative 2, so minus minus, we get a plus. T to the power 4. T to the power 4. This means 4 factorial over s to the power 5. So this is 1 over 2s plus 2 minus 4 factorial is 24. You can use a calculator, 4 factorial, then you see 24. Okay, what is Laplace 2? Laplace 2 is? Laplace 1 is 1 over s. Laplace 2 is 2 over s, because you can factorize the 2 from the 1. That's why 2, this is 1 over s. Okay, this is 2 factorial s cubed. That's why you get a 2 over s. Any questions? Yeah. When we just make any more questions? Next, we will move to the second property. Okay, second property called first translation property, where we will apply this. Okay, we will apply this into the first translation property. So look at the first translation property. Okay, this is the formula. This is the formula. Laplace EAT FT. When you see a product function that made up of one of the function is EAT, then we will use the first translation property. Okay, when you see a product function, for example, this one, this is the product function, E multiplied with cost function, and one of the functions is E. Then we will use this formula. Okay, I show you another. Okay, these are the exercise later. So you see, these are all product functions where one of them is exponential. E. So this kind of function will be used first translation property to do the Laplace transform. Okay, this is the formula. This is the answer. Okay, formula. So this is your FT. Okay, this is your FT. So from this FT, we will get the function, the Laplace transform, capital F in S. But this is S minus A instead of S. Okay, S minus A. So A comes from this A. Okay. So we will first identify the value of A, then we substitute the value here. For example, here, A is -4. Okay, A is -4 from here. So this one, the Laplace transform of this product function equals to Fs minus -4. Fs minus A is -4. That's why minus negative, you get a plus. So you write this out first. Okay, then okay, your A is -4. So this will be your Ft. Okay, this function will be your Ft. So your Ft is cos 3t. And on the right hand side, we want the capital F. Capital F means the Laplace transform of the lowercase of f. So we need to Laplace transform this. So this one, according to the formula, we have s over s squared plus a squared, where a is 3. Okay, but this is fx. What we want is fs plus 4. Okay, so we change all the s into s plus 4. This s into s plus 4, and this s also s plus 4, then only you square it. Okay, so this is the final solution. Okay, this is the final solution. Okay, so I repeat, when you see a product function where you need to Laplace transform a product function, and one of the function is exponential function, okay, EAT, this one EAT, then we use the first translation property, okay, EAT. So first we will identify the value of A, and then we substitute here. Okay, so you form this one first. This is your first step. Identify the A and substitute A into here, -4. So S minus -4, you get an S plus 4. Okay, write this out first. Then this will be your FT. Okay, this is your EAT. This will be your FT. So FT is cos 3t. And we need this capital F. Capital F means Laplace transform of this function. So we Laplace transform this. This one, you will get this. But your final solution is Fs plus 4 instead of Fs. So we change all S into S plus 4. This S and also this S as well. Okay, and this is your final solution. Okay. Now we try this. Okay, we try this. The formula is Laplace EAT FT equals to Fs minus A. Okay, this is the formula. So this formula will be included into your appendix as well. AT, FT, this will be Fs minus A, something like this. Okay, so this one, what is your A? 3. Okay, A is 3. So according to the formula, we have Fs minus 8. So minus 3. Okay, minus 3. So what is your FT? TQ. Okay, according to this formula, EAT, right? After you identify the A, you just take out the EAT. And then what is left will be your FT. Okay, just like this one, you take out, okay, identify the A, take out the EAT. What is left will be your FT. Then Laplace transform. Okay, T cube is 3 factorial over x4, which is 6 over x power 4. Then, what is the next step? We want this. We want this s minus 3. So we change all the s into s minus 3. Okay. B, what is your A? 3. What is your FT? 5 cos 2t. And here, F
S minus 3.
S minus 3. Okay, S minus 8. Huh? Okay, now Fx. All this while, this first translation is quite popular in some. Quite popular. This but normally when you see the first translation question, it will be some. Okay, cos 2t. Cos 2t.
S over S squared.
S squared plus 4. Okay, so we have 5x. 5x because you have this 5. 5 multiplied to this cos Laplace of cos 2t. Then finally, fs minus 3. So you change all the s into s minus 3. Okay, question 3. What is your A? A is -2. And your FT is sine 5t. And this will be Fs plus 2. Yes. Okay. We'll get Fs. 5 over S squared plus 25. And lastly, we want this S plus 2. It's B. In question B, what is your A? A is 3. Your FP?
F2.
2 minus T. Okay, this is your FT. And this is Fs minus 3. F2 over X minus 1 over S squared. Okay, then substitute S by S minus 3. students who join online class, if you have any questions, just put your question into the chat. Okay. Okay, E. Have you done E?
Yeah.
Okay, what is your A? Negative 4. Negative 4. So this is your F S plus 4. And your FT is T squared. Fs is 2 over S cubed. Okay, so we want this S plus 4. 2 over S plus 4 cubed. Those who join online class, I will just take the attendance from the team. What's your 8? 1. This is your F S minus 1. Your FT is this one. T minus hypersine 3T. So your Fs is 1 over S squared minus 3 over S squared minus 9. Okay, what we want is S minus 1. S minus 1 squared. S minus 1 squared. In the board, but from what I can see here, my screen, the writing is all in the screen. You can just click on my screen and launch it. Okay, one more property. One more property to go. One, this is called derivative property. Okay, derivative property. So when we will use this one, t to the power of ft. This is the formula. So when you see a product function where one of the function is t to the power of n, then we will use this formula. Okay, I give you some examples. T multiplied to a function, t multiplied to a function, t squared multiplied to a function. So whenever you see a t to the power of n multiplied to any of the function, then we use this formula. So if you look at the question A, this is a product function that contains the exponential function as well. So means that this question you can solve by either using first translation property or derivative property. You will get the same answer. And now we look at how to apply this formula. Okay, so now we compare this t, n is 1. Okay, n is 1. So your ft is cos 3t. Okay, if you look at the formula here, n, we need the value of n here. So if your n is odd, you have a negative sign. If your n is even number, you do not have the negative sign because we have a positive. Okay, positive. So this n here it represents how many times you need to differentiate. If n is 2, you need to differentiate twice. Differentiate this function twice. If n is 1, that means we differentiate fs one time with respect to s. Okay, now we look back at this. Okay, n is 1. N is 1. Ft is cos 3t. So we need this fs. So we Laplace transform this ft to get the fs. Okay, so cos 3t, you get this one. Okay, then we will start to Laplace transform the product function. Okay, n is 1, means that we have a negative sign. Okay, because your n is 1, you have a negative sign. And then d over ds, we will differentiate one time on this function. So what is this function? Here. This one. So means that we will differentiate this function one time with respect to s. Okay, we have a negative here. Okay, so to differentiate this, we have to apply the quotient rule because there is an s at the top and there is an s at the bottom. So we have to apply the quotient rule. So u over v means that vu prime minus uv prime over v squared. Okay, then simplify, you will get the answer. Okay, so I repeat, when you see a product function that contains one of the function is t to the power of n, then we will use the derivative property. Okay, this is the formula. Formula will be given. Okay, and we will identify the value of n first. N is 1 here. Okay, n is 1. So when n is 1, you have negative 1 about 1. So you have a negative sign here. And then n is 1 means that you differentiate one time. On this function, we will differentiate this function. So where we get this fs? From here. Okay, from this ft, you Laplace transform, you will get the fs. So we will differentiate this function with respect to s. Okay, so u over v, we use quotient rule, then we will get the answer. So if you look at the exercise, this is n is 1, n is 1, this is n is 2. So meaning that from question A and B, we differentiate one time. But C, we need to differentiate 2 times. Okay, now we try this. Any question? Any question for this? Okay, let's try the exercise. So this is the formula. Okay. So here identify your n. What is your n? 1. Your n is 1. Your ft e2t. Okay, e2t. So you need to find for the fs. Then you can start to Laplace transform this. Okay, Laplace. So Laplace transform this because your n is 1, so you have a negative sign. And then you have d over dx. Okay, so what is the function here? It will be here. So what is your e2t? After you Laplace transform, you have 1 over s minus 2. So this can be written as s minus 2 power of negative 1 because there is no s at the top. There is no s at the top, so we do not need to use the quotient rule. We don't need the quotient rule. You just differentiate as usual. Okay. Unless you have an s at the top, then you have to apply the quotient rule. Okay. So that's mean negative. Okay, how to differentiate this? Negative 1 s minus 2. This one minus 1 more. Negative 2 times. Differentiate this one, you get 1. So meaning that minus minus, you get positive. And this one will be 1 over s minus 2 squared. Okay, now I want you to try the second one, t hyper cos t. What is your m? What is your ft? Fs. Then Laplace is 1. Will be Okay, your FT is hypercos T, right? Hypercos T. So FS is
That's always good.
S over minus 1. Okay. This one I continue here. Mass T hypercos T is, okay, T n is 1, n is 1. So we have a negative sign. Then d over ds. Then we need to differentiate this function. Okay, so when you differentiate, you have to apply the quotient rule, right? U over v, U over v. So the formula is v u prime minus u v prime over v squared. Okay, then you just expand, simplify. Okay, this one you have s squared minus 1 minus 2s squared. S squared minus 2s squared, that's been negative s squared minus 1. And minus, when this negative, you put this negative into the denominator, you have s squared plus 1. Do you get the answer? Do you get this answer? Okay. Okay, next one. T squared sine 2t. Your n, your ft, your fs. Okay, your n is 2. N is 2. Ft is sine 2t. So fs is 2 over s squared plus 4. Done? Have you done this? Okay, so now Laplace t squared sine 2t is, okay, so -1 squared, we get a plus, so no negative sign. Okay, this one, when this is 2, okay, square, -1 square is positive. Then we have b squared ds squared. And we need to differentiate this function. And this function, we do not have s at the top. Okay, so we can write in this form, s squared plus 4 -1. Okay, we can write in this form, easier for us to do the differentiation, since we do not need to apply the quotient rule. Okay, no s at the top. Okay, so now when we start to differentiate, okay, when we start to differentiate this one,
Negative.
-2
Yes.
s squared plus 4, -2 times 2s. So after you differentiate one time, you left with another time. So that's why you have d1, ds1. Because we have done one time of differentiation, so this will be changed into this. Okay. Okay, now we simplify this one first. -4s over s squared plus 4 squared. Okay, simplify before we further differentiate. So negative, okay, we can leave the negative outside. Then apply u over v, quotient rule. Okay, quotient rule. So v u prime minus u v prime. Then v squared. Okay, the square, after you square one more time, you get power of 4. This one, when you differentiate this, you get this one. Okay, 2, and then this one -1, you have power of 1, then you differentiate this one, you get 2x. Okay, then simplify. Okay, we have s squared plus 4 here, s squared plus 4, and s squared plus 4. We can cancel out one set. Okay, because this is power of 1, right? This is power of 2. So we can cancel out one set. So this one, after you cancel out 1, you have 1 more. Okay, power of 1 minus 16s squared. Okay, this one, after you cancel out, no more. And at the bottom, cancel out one set, you have 3. Okay, then you can simplify. 4n squared plus 16 minus 16s squared. So 4 minus 16. Okay. Negative 12s squared plus 16. Okay, we can combine the negative to the top so that we have 12s squared minus 16. Okay, any questions? We have done one differentiation. One time. That's right. This means differentiate this function respect to s. Okay, differentiate this function, this one, differentiate this function respect to s. So when you have square here, meaning that let's say we want to differentiate, let's say we want to differentiate s squared. Okay, we want to differentiate s squared one time. So after you differentiate, this is the answer, right? After that you differentiate. If you want to differentiate this one more time, meaning that v over ds for this whole function. Okay, this one differentiate one time with respect to s. So this is the output. Then if we want to differentiate this output one more time with respect to s, then we have this differentiate this whole thing with respect to s. So this one, we will write s. This. Okay. In short, we are differentiating this one twice. Any more questions? Okay, we have done the topics for week 5. Let's make week 5 for next week. We have done. So meaning that we do not have class next week. Okay, so we will have class after you come back from your holiday. Okay, so any questions before we end the class? Okay, if no, then I will see you after the holiday. Selamat Hari Raya and happy holidays for all of you. Okay.